Hello, this is Byron Kennedy. I'm just going to give it 30 seconds and then we will start. So welcome to everyone who's on the line. Everyone else will be joining in the next minute or so. But let me start by just going through and giving a bit of an introduction to the webinar. So the webinar today is not going to be your normal boring PowerPoint webinar. We're actually going to do a walkthrough of the factory, and we're going to show you what we do here at Speed3D, and we'll show you the printers actually in action working, printing some push plates today. By way of introduction, my name is Byron Kennedy. I'm the CEO of Speed3D. So today, as I said, we'll do a walkthrough of the factory. We'll do the live push plate. We'll wrap this up in 30 minutes. So it'll be short, sharp, and hopefully enjoyable for everyone on the line. So a couple other things. So today in the factory, we only have a few people in the factory today due to social distancing regulations. Now, one of the advantages of 3D printing, of course, is that you don't need a big staff of people running the printers. So we've got a couple of people out the back at the moment, but that's about it. Everyone else is working from home. So you'll see a few people walking around, but not a lot today in the factory. So let me start with an introduction of Speed3D and who we are. So Speed3D, I'm actually in the office in Melbourne, Australia. So we're an Australian-based company. We're a manufacturer of metal-based 3D printers. So we actually build the printers here and then we sell the printers. So in terms of today, the webinar is going to focus on a new product which we've developed over the last month, and that's called activated copper. So what activated copper is an antimicrobial copper that you can apply to high touch surfaces. So what I'm talking about there in high touch surfaces are things like door handles, push plates, rails, and other things that people touch frequently. So the reason for this activated copper material is that it has a very interesting property that it is antimicrobial. So antimicrobial copper has been known for centuries. It's a unique property of copper in that it kills bacteria and viruses upon touch. So for instance, if a virus or a bacteria falls onto or gets touched onto a copper surface, such as a push plate or a door handle, the copper can actually kill that virus or bacteria in a certain period of time. So at Speed3D, we knew of this antimicrobial property of copper, and we thought, I wonder if this can actually kill the coronavirus that's around today. So we actually went out and independently commissioned a clinical laboratory to do a study for us on our activated copper to see, will activated copper actually kill the coronavirus, the SARS virus today? And what we found was very, very encouraging results in that it killed 96% of the virus within 2 hours. So we proved that, yes, the activated copper does kill the SARS virus. So today, and we released that information about a week and a half ago. Today we're going to give a short overview showing how now we can print some plates, and those plates would be ready then for use on, say, a toilet door or something like that, as a push plate on a toilet door to open that door. So that's what we're going to show you today. We'll also show you a couple of the other machines that we have out the back, and we'll have a bit of a walk through the factory. So enough of the introductions. I will grab my phone, we'll walk out. I'm just going to put on some headphones here to block out some of the noise. So we have a dust extractor in the factory, which is a bit loud. The printer itself is not too bad, but the dust extractor does make a bit of noise. So I'll walk out. We will have a look at some of the equipment out the back. We'll print a plate. And if any time you have any questions, hit the Q&A button at the top. Send them through at any time. When I get back, I'll then answer those questions. So I'll grab my phone and let's walk out the back. So this is the Speed3D factory, and let me start by just having a look at the what we call speed cell. So speed cell here is a printer followed by a furnace. So you can see the furnace there and a CNC. So normally in 3D printing, you start with your printer, but the parts, when they're printed, then need to be finished in some way. So usually you will put them in a furnace, which is that grey box you see there, and then they'll usually be finished with a CNC machine, which is what you see here. So what you see with the speed cell, which is one of the products we sell, is a full production line here. So in this area here, you can see the full production facility of a printer, a furnace, and a CNC machine. And this is called speed cell. So I'll keep walking along here now, and I'll start by going straight over to our light speed printer. So this is light speed. So we have two machines that we sell today, light speed and warp speed, which you can see there in the background. Light speed, the difference between these two machines is that light speed produces parts about 300 by 300, where warp speed produces bigger parts. So let's wander over to warp speed, light speed now, sorry, and I'll show you what you see here now is the robot, and then in the background I'll explain the printing in a moment. So this is our touch screen, and over here is a display screen. So you can see mounted up there on the end of the robot is a blank push plate. So push plates using toilets and those sorts of things to open doors. That's a stainless steel push plate, and what we'll be doing is coating this in activated copper. So the screen itself, I'm just going to put the phone onto the window here, and then I'll put the start button for you to be able to see this printing. So just bear with me for one moment while I do that. All right. So now what you see, let me just pick up my microphone so you can hear me better. What you can see in front of you here is a stainless steel push plate attached to the end of the robot arm, and the stationary nozzle that you see below the printer, so the black nozzle, what that's actually doing is spraying metal powders at supersonic speed. So what we do is actually we spray, in this instance we're spraying activated copper at about 600 meters a second, so that's twice the speed of sound. And when that powder hits a plate, it then sticks. So what you can see here is now we're covering this stainless steel plate in activated copper, and what that's doing is therefore is creating a antimicrobial surface on a push plate. This particular push plate, if I look over on my screen, this is going to take about 7 minutes to print. So what we're actually doing here in 7 minutes is taking a normal stainless steel push plate and converting that into an antimicrobial push plate via the activated copper material. And as I said, it's about a 7-minute print time. So I'm going to walk around in a moment and show you in a few other things around in our factory here. But in that time, we will go from a standard plate to a fully antimicrobial plate in that amount of time. So it's a fascinating process. So the whole process done in air. So how it actually works is we have a standard compressor outside, and that then powers the rocket nozzle. We then heat that air up to about 500 Celsius. The rocket nozzle then takes that hot compressed air. We then inject a powder into that, and that all then goes through a rocket nozzle, and it takes this hot compressed air, turns it into air at about 1,000 meters a second. The powder is then injected into the nozzle. It gets accelerated up to about 600 or 700 meters a second, and then hits this plate and then sticks. So let me just show you the display screen of our printer here. So over here you can see the display feedback from the actual printer. We have a camera which is actually showing, but that's difficult to see. So you'll see down the bottom the head pressure is about 30 bar. We're running this, as I said, at about 500 Celsius. And this whole print time is about 7 minutes. So you can see in the time that I've spoken, we're already a third of the way through. So it's a very, very fast process, and it coats these plates very quickly. So let me just go back over the other side and we'll just see how this print is going. So I'll wander around here, And you can see, you know, half of that print's already done. So as I said, it's a very quick process, and it's a very effective way to coat these parts very, very quickly. There's very little labour involved, as you can see. Like I'm able to run this and do a webinar at the same time. So that's the amount of labour involved. After the print is done, you cool down, and then you can open the printer door and get the part out straight away. They're a little bit hot. They're about 50 or 60 Celsius, and that's just due to the amount of air that we're blowing over the plate. So that's creating a bit of friction, which is also then creating a bit of heat onto the plate. But certainly you can pull that out with a set of gloves and then just cool that down, and the plates are ready to go. In these particular plates, we will then finish them afterwards, so we'll linish them or use a wire brush to finish them afterwards. And that creates a surface finish, which is then acceptable for end use. So in addition to push plates, we can actually coat any part. So we're also doing things like door handles. We're also doing pull handles and those sorts of things. So, you know, a typical push plate on a door, you push on one side, and then on the other side, you then have a pull handle. So you want to be able to have antimicrobial on both sides, and that's what we are doing with this particular process. So what I'm showing you today is just a simple push plate, but there's also door handles and pull handles and other things like that which the process can do. So the beauty about a printer like this is it's not just set up for one particular product. It's set up so you can do as many different products as you desire. So all you need is a fixture to be able to mount the plate on in this instance. But if you want to do a door handle, you just need to be able to mount that door handle in some way. And so the same printer could be used to do, you know, 50 push plates now and then 100 door handles in the afternoon. So they're very, very flexible. You can also print full parts, of course. So it is a full 3D printer. That's what the technology was originally developed for. But now we've added to that feature by putting this coating technology into it as well. So let me just go back around the front. We'll see how it's progressing. So we've got about a minute left. And I will show you the ending process because it is quite interesting to watch. So it's finishing up in about 1 minute time. So what you've seen here is a push plate being excuse me, fully coated from start to finish, and therefore, in 7 minutes, you can produce about 9 of these push plates in an hour, and therefore, in a single shift, you're going to do 70 or 80 push plates. So very, very quick, very efficient process to be able to put these antimicrobial surfaces on these plates, and also then the door handles. So so the materials, so currently this is set up for copper. We can also do other materials, of course. We do a lot of aluminium, we do bronzes, brasses, and we're also setting up the stainless steel. But in terms of the antimicrobial properties, which is the materials that we're presenting today, it's all about copper. So this is an activated 3D copper finish. Let me just go back around the front. So you can see here what we're doing is we're just spraying around the holes where the bolts go through. It'll also then put a finishing coat just around the surface to clean up the edges. So we're just doing that now. And then the part will be finished. All right, so that's the finished push plate. So you can see here, part complete. That'll then depressurize, and then we can pull that printer up. Then we can pull the part off. I'll walk around now and show you one of the other machines here. So one of our engineers is working on the machine. So this is our warp speed machine. So the warp speed machine is the same as the light speed machine, which I just showed you, but it prints very, very large parts. So out of this machine here, we print parts up to about 1 metre diameter. So you can see, let me just come over while Rianne's working on it here. You can see the difference in the two machines is the robot. So this is a much larger robot, and how we've got it set up just at the moment, it's actually outside the machine. So what that means is it prints the part, and then we open the windows, and it'll actually bring the part outside the machine. And that's important because when you've got big, heavy parts, you know, parts which are 30 or 40 kilograms, are actually very difficult to handle. So the printer does like a bit of a yoga move to be able to get these parts outside. But that's really what we're showing here is how you would eject the part after it's produced. So this is a large machine. This machine in itself has been sold to the Defence Forces, so we're just doing some commissioning now. So let me go back inside now. So there's our Lightspeed machine, depressurized. That'll be ready for the parts to pull out now. When I say depressurized, it's just turning the pressure off the nozzle. There's no actual pressure inside the build chamber, I should say. It's just for safety reasons we don't open it until the pressure in the nozzle is down to 0. So let me walk back into the office now, and then we can go through some questions. And so if you have any questions, please forward them through now. Happy to look at them when I get back into the office. So let me just walk back in now. I'll actually just show you on the way back through some of the developments that we've been doing. So it's quite interesting. When you start with a particular technology, you have to go through a series of tests. You can see on the wall here, this is our wall of tests that we started with. So you start with a dot, and then you move to circles and squares, and then you add a lot of sophistication in. It's very difficult to see with the small camera, but this showed some of the developments we did over time, and you can see here now on our table a whole bunch of parts that we produced for various applications, and we've done during the course of the development. I'll walk back into the office and I'll show you also some other parts that we produced, which are not activated copper. They're either aluminium or copper in most instances, and you can see some of the other parts that you can produce with the printer. So back in the office now. Just put my headphones down, and you can see some of the parts that we're producing with this printer. The orange parts are generally copper, and the silver is generally aluminium. You can see things like these are here. These are full copper door handles. So full copper is people ask, why wouldn't you be producing full copper door handles? Well, the reality is copper is quite an expensive material. So the better way to do it is start with something like a traditional door handle, which is, you can see here, and then coat that. So the coatings we're putting on are about 0.5 millimeter thick. So that's a much more economical and much quicker way to produce than a full copper door handle. So just some other examples. So these are full aluminium door handles. These are some of the surface finishes we've been looking at on the touch plate. So you can see some rough finishes all the way through to very, very shiny and smooth finishes. It's important in hardware to be able to produce a finish which is acceptable to end customers. And then some of the other parts which we've been producing over time, handles, and you can see our Thor handle. If you actually have a look on our website, you'll see our Thor video. So that was the Thor hammer, and some rocket nozzles and other parts in the back there as well. So let me sit back down, and then I'll just take a look at what questions we have, and I'll answer them. So if you have any other questions, please feel free to send them through now while I just set myself back up. All right, so thank you for bearing with me while I just set myself up. So I'll just have a look at the questions we have coming in now. So the first question I see here is, what makes activated copper different? Yeah, so why is it different to normal copper? Well, really the interesting thing about activated copper is the printing process, or the spraying process, which we actually do here. So what happens is we're spraying these metal powders at supersonic speeds. When it hits the surface, it then sticks, and it creates this quite a unique microstructure. So this microstructure is quite different to normal cast or forged copper, and that gives us these unique properties, which is quite different to typical forged material. Let me have a look. Other questions here. How long does it work? So how long do I presume that means how long does the antimicrobial properties work? The antimicrobial properties are continuous. So as long as that door handle or that touch plate is kept clean, the antimicrobial properties continue to work continuously. So this is a continuous solution. So it's not a solution which is just a one-off, works for 12 months or something like that. It's continuous protection, and it works not just with the coronavirus, as we've proven in our test results, but with other bacteria and viruses as well. So it works across numerous things, and it provides this continuous protection. Question here is, what are the cost of printing per meter squared? So per meter squared is a difficult one. It's probably better doing it per kilogram. So roughly speaking, it depends a lot on the volumes and things like that. But in terms of estimating the cost, you're looking at, so this is cost if you have your own printer and you're building parts. You'll be looking at somewhere in the order from $40 to $60 a kilogram to be able to print activated copper. Now there's lots of assumptions in there, but roughly let's call it in that range. So a typical push plate, maybe 100 grams. So you're looking at about $4 to $6, say, additional cost to the straight stainless. So it's a very economical process, and also very quick. So, that's part of the appeal of this, is not just being able to produce one-off parts, it's really being able to take this into full production. So let me have a look at some other questions. Why 3D coat rather than print them? So the advantage of the coating over 3D printing is that it is cheaper and quicker. So typical, like the door handle I just showed you, typically, the production of a straight door handle like that is done from rod, and the rod itself, it's actually very, very cheap. So trying to produce the copper part as a solid part, you can do that, no problem. So we can print it, as I showed before. But the economics works better if you just put about a 0.5 millimeter coating on. So some of the other questions we get are things like, what about just doing electroplating? Well, yeah, you can electroplate copper, but the reality is the electroplating is very, very thin in general. And when we've had a look at the commercial applications, we've seen a lot of the electroplating materials that have worn off. So you want, especially when you want a high wear surface. So this is really targeted at commercial applications, things like hospitals, schools. We get a lot of use of that material, so you don't want to be able to wear that material off because you'll lose that antimicrobial properties. But it's also equally as effective at home as well. So having an antimicrobial front door handle is certainly something that's going to become more relevant in the future. Another question here is on the dimensions. So the smaller light speed machine, that was the one that we were printing on today. That was printing parts up to, so the maximum size on the small machine is about 350 by about 300. And you can do one part, or you can do multiple parts, by the way. So when we're coating things like door handles, at the moment we've got 2 door handles mounted simultaneously, and then we're coating both of those at the same time. So we just put a video up on LinkedIn. You can see, it's a fascinating video showing it's like a ballerina dancing. And that's the smaller machine. The larger machine, so the warp speed machine, the second one that I showed you today, that'll print parts up to 1 meter, so difficult to fit in. 1 meter by about 700, and that'll also do a maximum weight of about 40 kilograms. So in terms of coatings, that's for the larger coatings of very, very large parts, or building large parts. Like behind me here, this one here is a rocket nozzle. So that was about a 30 kilogram rocket nozzle, and that took about, I think it was 5 or 6 hours to print something like that. So, very, very big parts take longer, obviously, but that's done on the bigger machines. So, so let me see. I think that's all of the questions that I've got coming in at the moment. So, if there's no other questions, what I wanted to say is thank you for joining us. It's a pleasure to be able to show you the technology. It's also enjoyable to be able to print something and you can watch it from start to finish in real time. All right, I did get one more question. How do we print a round handrail? So what I would do to see that is check in on LinkedIn, because what we show there is printing a round, it's not a handrail, but it is a round door handle, and you'll be able to see exactly how it is that we do print it. So if I can use it as an example, so we have a nozzle down here, and then we have the round handrail. There is a way just to maneuver that handrail around, and that will enable us to print both sides of that handrail. So, but the video that we're just posting now will show that much more clearer than my explanation. So, do you sell activated copper? Sorry, just reading one more question that's coming in. Do you sell the activated copper and the printer? Yes. Our main business is selling the actual printer, so that's a good question. We are doing pilot runs for people, so we're doing pilot runs of a couple of hundred parts or something like that. But our real business is selling the printers. Now, depending on the applications, we do have some service bureaus in different parts of the world. So in Germany, one of our service bureaus is Fit AG, and they could print parts, for instance, in Germany and Europe. In Australia, we'll be printing parts, and similarly, we have other contacts also printing parts in the US. So, so yes, we will do parts, but primarily Speed3D's business is actually selling the printers. For questions, what I would do is just send them directly to contact@Speed3D. If you look on our website, there is a link in there, and that'll either get to myself or one of my colleagues, and we'll answer any other questions. Contact@speed3d.com. And I'd like to say thank you for everyone for joining. Pleasure to be able to show you the technology, the factory, and everything we do. One last cost, the cost of the printer. So roughly speaking, it depends on your region. So just drop us a note on that, and we can let you know what the cost will be and who's the best person to talk to. So Portugal, I will put you in contact. If you drop us a note, and then we'll put you in contact with our head of sales in Europe, and he can provide you with all that information. So once again, thank you everyone for joining. It's a pleasure to be here, pleasure to present the technology. Any questions, just drop us a note, and check out the video either on YouTube or LinkedIn. Thank you.